Hi everyone, this is lesson 1.6, Powers of Rational Numbers in Grade 9 Academic. You should have your handout with you and you can pause this video at any time if you need to slow down or write down the notes clearly. I will explain to you how each question can be done. After the lesson, you are going to work on your homework, which will be given to you by your teacher. Mine's on. Write an expanded form and then evaluate. You have 2 to the power of 4, negative 2 to the power of 4, or negative 2 to the power of 4 with no brackets. What's the difference? When you look at 2 to the power of 4, you are multiplying 2 by 2 by 2 by 2. Since these are all positive numbers, you will end up with a positive answer, 16. In the second case here, because the brackets only surrounds 2, that means the exponent 4 is only going to affect 2, but not the negative 1. So the expanded form of this expression is negative of 2 times 2 times 2 times 2, which is negative 16. In the case of negative 2 to the power of 4 with brackets, it means negative 2 times negative 2 times negative 2 times negative 2. Well, negative times negative is positive. Another negative times negative is positive. So positive times positive is positive. Therefore, you have positive 16. So now we have reviewed some of the notations with negative numbers and negative bases and powers. We're going to see how we can evaluate expressions that has a fraction or rational number as the base raised to an exponent. Example 1. Evaluate. A. You are asked to evaluate 1/4 to the power of 3. So we can think of this question as a repeated multiplication of 1 over 4 times 1 over 4 times 1 over 4. So the numerator will be 1 times 1 times 1, which is 1. The denominator will be 4 times 4 times 4, which will give us 64. So the answer is 1 over 64. Question B. 3 over 5 to the power of 2. So you can actually calculate this answer using the same method as part A, but you can also see the exponent 2 as being shared by 3 in the numerator and 5 in the denominator. So we can write this expression as 3 to the power of 2 over 5 to the power of 2. And then you work out the answers. So 3 squared is 9, 5 squared is 25, so the final answer is 9 over 25. So now it really is your choice in terms of how you want to do these calculations. C. So you have negative bracket 10 over 11 to the power of 2. Remember, the negative sign does not affect the square, so we should just write that down in front of what's going to happen next. I will distribute the 2 to the numerator 10, so it's 10 squared, and the denominator 11, so I have 11 squared. And work out the answer. You get 100 over 121, and don't forget the negative sign in front. D. We have negative 1 over 2 to the power of 4. So this is a repeated multiplication of negative 1 over 2. If we remember the rule, if I have an even number exponent, like 4, and a negative number, whether it's a whole number or a fraction, as the base, the final answer should be positive. The proper way to write this, if we're going to show our work, is to make sure as we distribute 4 to the numerator and denominator, we need to include brackets around any negative numbers. So here we have -1 in brackets to the power of 4 divided by 2 to the power of 4. The answer is 1/16. Example 2. So now let's take those skills and apply it to bigger questions. So when we evaluate exponential expressions with exponents and powers, we still have to follow BADMAS, or the order of operation. Let's calculate -6 in brackets squared minus 7 squared. Well, negative number to the power even number will work out to a positive number. 6 squared is 36. Minus 7 squared is 49. So 36 take away 49 gives us -13. Question B. In brackets, -0.2 to the power of 2 plus 5 times 1.4 minus 2. So if you look across, the plan is we deal with the brackets first and then exponents. Here we also have brackets and we have a multiplication. So we know what to do first and what to do later. So work out -0.2 to the power of 2 is positive 0.04. I should simplify brackets before I multiply, so I just put down plus 5 and work out 1.4 minus 2, which is -0.6. I have an addition and a multiplication. Do the multiplication first. This is 5 times -0.6. It is -3. And lastly, subtract 0.04 by 3, you get -2.96. Part C. We have a lot of mixed fractions. We are squaring fractions and we are subtracting. So best practices says we are going to convert all the mixed fractions into improper fractions first. So start with -5 and 1/4. So 5 times 4 is 20. 20 plus 1 is 21. So this is -21/4. Plus 4 times 2 is 8. Plus 1 is 9. So we add 9/2 squared. Minus 7 times 3, 21, plus 1, 22/3. And then BADMAS says, simplify the brackets first. So to add a fraction out of 4 and fraction out of 2, the common denominator is 4. So there's no change to the first fraction, it's -21 still. But for the second fraction, we have to multiply both the numerator and denominator by 2. So that becomes 9 times 2, 18. And then we copy everything else. Simplify -21 plus 18/4. It's -3/4. Copy everything else. And now simplify the power. -3/4 squared is positive 9/16. Subtract 22/3. Now to do the subtraction of the fractions, I need to get a common denominator. And the lowest common denominator is 48. So we need to multiply 3/3 in the first fraction and 16/16 in the second fraction. That will give us 27/48 minus 352/48. Simplify your numerator. It becomes -325/48. over 48. And that's the end of this question. Example 3. There are a lot of negatives in this question, so simplify as many of those as you can first. So I have negative 3 over negative 5. That's simply 3 over 5. I have negative 1/2, or negative 1 over negative 2. Negative negative makes positive, so this is positive 1/2. Negative 3 over negative 5 can be written as 3 over 5. Other than that, all the other signs and symbols should stay the same. When we have a big weird fraction like this, we can look at the numerator by itself, first, and then simplify last, okay? So let's work out negative of 3 over 5 squared. That's negative 9 over 25. And then we need to simplify 1/2 minus 3 over 5 in brackets. Look for the common denominator 10. 1/2 becomes 5 over 10, and 3/5 becomes 6 over 10. So now we have negative 9 over 25 in the numerator over, well, negative, so it's really 1 over 10. The big long division line really means division. A fraction line means division, sorry. So we can rewrite this as negative 9 over 25 divided by 1 over 10. But you also know that dividing a fraction means multiplying by the reciprocal or the flip of that fraction. So we're really multiplying by 10 over 1. Reduce your fractions, and you get your answer, negative 18 over 5. And here's your last example. Jason buys a cell phone for $1,200. Each year, its value is expected to be 70% of its value of the previous year. Find the value of the cell phone after 5 years, and then generalize the value of the cell phone after n years. So first, we need to understand the meaning of 70% of something. Well, the fastest way to find 70% of something is multiply by 0.7. So using a chart, we can use the first column to represent n, the number of years, and second column, the value of the cell phone in dollars. So in the very beginning, year 0, the value of the phone is $1,200. In year 1, it is 70% of 1,200, so 0.7 times 1,200, and it becomes 840. And then in year 2, you multiply 840 by 0.7, that's 588, and so on and so forth. Let's see if there's really a pattern. Well, in year 1, we multiply by 0.7 times 1,200. Year 2, we are really doing 0.7 of 0.7 times 1,200. Year 3, we multiply this previous result by another 0.7. So what is happening is that the 1,200 is always there, and as the number of years go by, you just increase the number of times you multiply 0.7, making that a power of 0.7 that you're really multiplying by. As a result, the exponent here matches the year number. And so in year n, to calculate the value of the cell phone, it will be 0.7 to the power of n times 1,200. So that's the end of the lesson. You can now move on to work on the homework assigned by your supply teacher.